I'll have to look and see if, was I recording the first part yesterday? I don't remember, but to refresh our memories, yesterday, what did we do? We set up our two-dimensional motion problem situation, and basically all we said was, this is a triangle, and I know the sides. This is 400, this is 300, that's 500. Okay, so if I know how much farther below where it started this is going to go, then I already know y and I already know x. Technically, I guess this y should have been negative. Interesting. That y should have been negative. Let's see if that makes a difference. Because the x is positive this way, but the y is negative. So the y should be below. And then if we then use our equations, so we wrote out the two-dimensional motion equations. We plugged in the cracked initial velocity vector, and then we solved that. Yeah, we put those all together and combined it in one big equation and solved it for t. And that is how we got this, 26. So what happens to this whole thing if this is negative? Plug that in. Good. Okay, so do that calculation for the time yourself. So it's 2 times minus 400 times the tangent of divided by acceleration. Much better, much better. I get an answer of 11.28, let's just go 11.3 seconds. Okay, so that works much better. It makes the problem more interesting, right? Because that means like that truck that you thing goes, and then finally it moves, boom, and it explodes. So our answer doesn't change. The truck is still safe, but it makes it a lot more interesting. And then the second part of this is, well, technically the first part of this is how do we go back and get the initial velocity? So if you take x is equal to v0 cos theta t, then v0 should equal x over t cos theta. But x is 400 divided by 11.3 times the cosine of 30 degrees, and I get 46.2 meters per second. Yeah. I'm going to plug all that crap in. Well, did anybody else get 11.3? Okay, so a lot of people are. So I'm going to go ahead and